Greetings students. Today we will start with electric field. Electric field is a space, around a charge in which another charge experience a force, that is force experience a electrostatic force. So electric field is a space around a charge in which another charge experiences a electrostatic force. For example, if we take a source charge Q and if we bring another test charge, a small test charge, small q, in the space around the source charge, then the force experienced by the test charge will be known as electrostatic force, and this space in which we are experiencing this force, this space will be known as electric field. So electric field is the space around the charge in which another charge experiences electrostatic. By convention, we make electric field lines. From positive charge, we assume these lines is going outwards, and by convention, we take in negative charge as the field lines coming inside. We can write another definition for electric field. Electric field due to a charge Q at a given point in space may be defined as the force that a unit charge or unit positive charge would experienced if placed at that point. Electric field at a given point P can be written as E, which is at distance r apart from the charge, as k q upon r square and in the direction of r. We can also write this as 1 upon 4 pi epsilon naught q upon r square in the direction of r vector, that is given as by the r cap. We also can write E vector as half vector divided by the charge q, the force experienced by a unit positive charge. If we put in this formula that q equal to 1, if we put in this formula that q equal to 1 coulomb plus 1 coulomb unit positive charge, then the electric field or electric field intensity will be the force experienced by that unit positive charge. So it will be the force experienced by the unit positive charge. Okay, if we can put q equal to 1, then ER equal to half R. We also can write this in a different format. E vector equal to limit q tends to 0 but not 0, okay, half upon q. When q is negligibly small, okay, but the f upon q is finite, then we can define E as, next we have electric field due to system of charges. Let's say we have a system of charges. I have Q1 charge, Q2 charge, Q3 charge, Q4 charge. And because of these charges, I need to find E on a given point P. E at a given point P. All charges are positive, so we will define E1, we will define E2, E1, E3 first along the vector which is in the direction of the point P from the charge. So we have E1 vector, we have E2 vector, E3 vector and E4 vector. Okay. The electric field at a point due to a system of charges is the vector sum of the electric vector sum of the electric fields at that point due to individual charges. Okay, so electric field at a point due to a system of charges is the vector sum of electric field at that point due to individual charges. So the combined or the net electric field will follow the superposition principle, and it will be given as E vector equal to E1 vector plus E2 vector plus E vector plus, we also can write this as follows, as a function of the distance between them or the position vector. So E1 vector R plus E2 R vector plus, we can put the values, that will be K Q1 upon R1P square into R1P cap. Where is R1P? R1P is the vector joining Q1 and P point. R2P will be the vector joining position vector which is joining Q2 with P, same as R3P, R4P. Okay. Next we have K Q2 upon R2P square in the direction of R2P vector, so R2P cap plus KQN upon R NP square R NP. We can write this formula as follows: ER at point P will be given as K summation of QI upon RIP square into RIP cap, where I equal to 1 to n. So this is the vector quantity that varies from one point to another point in the space and is determined from the position of source charge. In next class we will study about the physical significance of electric field and electric field in detail about the field lines and then electric flux. Thank you.